Let's get that out of the way. So now we are talking about lenses. And my next slide, don't write it down for all you people who like to write ahead. Actually, Justin is the one who writes ahead the most. But don't write this first one down. I just stated to you already that we've seen what happens when light enters prisms, all right? And you can imagine this almost looks like a lens, but I actually have it made up of three kind of different prisms, two triangular prisms and a rectangular prism. And we've already seen, well, what happens to a ray that comes right down the normal? What happens to a ray that comes right down the normal, straight down this flat edge of this plastic prism? What does it do? Oh, we're not talking about the reflection this time, right? I know there is a little bit of a reflection, but I'm worried now about the transmission. How does it go through? Straight through. So this guy's going to go straight on through, just like that. This guy, you'll notice it's heading at an angle, and it's going from fast to slow, and its normal is right there. And if it goes from fast to slow, how does it bend compared to the normal? Oh, no, 50-50. Try again. Near the normal, towards the normal. So this is going to bend down, and now that it goes back into the air, it's going to bend away, and it bends down again because it has a new normal. So after two bends, it makes a turn. This ray will do the same, except it will be the opposite. All right? So we can put two triangular prisms together with a rectangular prism, and we can get those rays to bend to one spot. Now that's not a lens. What is a lens? A lens is if we take this particular type of prism and we grind off all those sharp edges and we make that into a nice smooth changing prism, then we've got a lens. All right? So that's what we get when we smooth those edges out. So let's talk about types of lenses. That you are writing down. All right? Lenses can be ground down or cut in many different ways. Converging. What did I say? Oh, all, yeah, sorry, you're right. All whoops, back up. You're right, that's a mistake. All converging lenses. Yep, very good, good check. I haven't used this note in a long time. They are thicker in the middle and thinner on the edges. There are different ways in which we can achieve this. Now, I just use the oval tool to draw that. You know what I mean? When you're building things in kind of Office and PowerPoint, you can make a shape. But what I'm trying to simulate there is a lens that kind of looks like this. You can see there it's bulging out on both sides. See that lens? It's bulging out on both sides. That's called a double convex. Remember, our convex surface is the bulging out surface. So it's kind of sticking out there and sticking out there. It's getting fat. It's convex on both sides. So that's called a double convex. But because it's fat in the middle and thin on the edges, it will be converging. The rays will come together. I can have a concave convex. This lens came out of an overhead projector. Remember the old overhead projectors? I don't know if any of your teachers ever used overhead projectors. Did any of your teachers ever use an overhead projector? You know, they write on it and it projects. You know the thing at the top that kind of moves around? Well, it's got a mirror in it. It's got a couple of lenses in it. And we had some old broken overhead projectors. And so I took them apart, and this came out of the top. And you can see here, it goes deep in on this surface here. In other words, it's concave, and it sticks out on that surface there. It's convex, so that's called a concave convex lens. but because it's fat in the middle and thin on the edges, it will be converging. It will behave like a magnifying glass, just like this, exactly the same. Most people's glasses are like that, all right? So mine are converging, and you'll notice that they bulge out a little bit on the front because they have the curve of the frame, but then they curve in on the back, but in the end, the edges are thin and the middle is thick. That's what makes it converging. We can also have something called a plano-convex. That simply means that it is flat on one side, but bulging out on the other side. But notice how all of them are thick in the middle and thin on the edges. Okay, so let's now draw all the important parts of this, and let me show you what I've got here. Okay, so last time I drew that on a piece of paper to show you. Here's the way I want you to draw it. I'm going to kind of guide you. Take your ruler and draw the middle line, and that is the principal axis. All right? Take the ruler and draw the middle line, and that is the principal axis. Yeah, you're going to need a ruler for the lab as well. Oh, no, take a look. Everybody look at the back of the room right there. Oh, who's got a laser? Who's got a laser? Oh, that's fun. Let me see. I'm not going to take it. That's fun. You were pushing the button in your pocket, and I was seeing it on the back wall, and I'm like, I'm not playing with lasers right now. And then when you turned, the laser moved. Keep it away. Oh, I bumped my cart. In my haste, I bumped my cart. All right. Yeah, I thought something was a little odd. I'm seeing some laser light on the back wall. All right, that's fun. Most teachers would have gotten away with that, but I spotted it. All right. Okay. Principal axis. Are we okay with that? Now notice what I drew here instead of drawing an actual lens. That's the way we write that, so we don't have to actually draw a fat lens. So notice it's simply a two-headed arrow that points up and points down. So notice what the arrow is representing. The arrow is representing the fact, and I'm hoping I can write on my smart board because I did bump it. The arrow is representing the fact that that is thin, all right, because it's pointing together at the top, that it's thin, and that it is thick in the middle. So because of the way that particular arrow points, you need to imagine as if those arrows are bending around like a lens and making a thick middle and a thin end, all right? So this is, you're going to imagine that it curls all the way around. In other words, it makes it like it's a fat lens. So that's the way we draw it. If we're drawing the other type, the arrow is going the opposite way, okay? All right. So take your ruler, and I want you to choose, oh, and I do need to mark some extra things on here. Let's pick a distance of 2.5 centimeters to mark off these spots, and they're on both sides, all right? 2.5 centimeters, and mark off the SF and the PF, all right? So use 2.5 centimeters, mark off the SF and the PF. And again, I want to write on the board, so I've got to get things a little better here. It's pretty close, pretty close. All right, I'm in business. Okay, so the PF is called the principal focus, all right? And the SF is called the secondary focus. When it comes to lenses, there's two focuses. And the reason there's two focuses is because you can take a lens and you can turn it around, and the lens works just like it did if you had it this forward way. So it doesn't matter which way the light enters the lens, it will always have a focus. So there's one on each side. The principal focus is on the opposite side to where the light comes in. So you can now draw those two rays coming in and have them cut across the principal focus. So the principal focus is where the parallel light rays meet. That's how we can find the principal focus, just like we found the focus with the mirror. We shine the light rays in, and they meet at that point. On the front side is the secondary focus. Now, there is another important part that you're going to work with that I want you to add. If you have the focuses at 2.5 centimeters, I want you to go out to 5 centimeters on both sides. All right? And what did we call that spot that was twice as far out as the F when we were dealing with mirrors? Yep. That was the center of curvature. Don't call it a C, because it isn't a C. There is no center of curvature. There's actually two curves, and it's very complex how to figure it out. So we're going to simply call these 2 points 2F and 2F. We're simply going to call it twice as far as F. But they're still important spots. Okay? All right. And this little F right in here, that's supposed to be that distance between the lens and the focal point. Okay? The lens and the focal point. All right. So that's how we deal with converging lenses. We have a PF on the far side and an SF on the close side. All right. Let's talk a little bit about diverging lenses, and then we'll get to our two labs. I'm going to just give everybody a little chance to finish writing that stuff down. I want you to write the definitions as well. Yes, sir. What do you got? You got a question? So PF is the principal focus. SF is the secondary focus. F is the focal length, the distance. Oh, look at what that says. See that screw up? Lens. It's the distance from the lens to the focal point. We're not in the mirror business anymore. Yep.
I have a question. If you were to take the ray and then flip it around, say it's coming on an angle, would it point back out to parallel?
That's what we're going to discover. But it has to go through a certain spot. Where would it have to go through in order to come out parallel?
The principal focal point?
Yes, correct. Or we could start on this side. What would it have to go through if the ray started on the left side? Yeah, if it went through the secondary, we're hoping to see that it comes out parallel. That's exactly what we're looking to discover. Correct. Still waiting for some writers. That's okay. Good to go? Okay. Oh, we know that that's principal axis. Don't worry about that. Diverging lenses. Don't put types of lenses again. Just put number 2 underneath there. Diverging lenses. You don't need to shade in the lenses. If you're drawing them, I would like you to draw them. How to draw something like that, right? Just make 2 big long lines and then have it curve in. This guy's a little trickier. The convex concave, again, you need to have two thick lines, and then you got to have one curve in, and then the other one curve less. The inside one is a big curve, and then that outside one is a more gradual curve. Again, the center has to be thinner than the edges for diverging. So the center is thinner. The middle is thinner than the edges. Again, every one of my diverging lenses, again, thin in the middle, thick on the edges there, pretty fat there. Again, those people, and we will find that those people who are nearsighted, that can see near but can't see far, they will have lenses like this that are thinner and thicker. All right? People who are nearsighted that have diverging lenses, when they put their glasses on, it makes their eyes look smaller. And people who are farsighted and can see near, that have magnifying glasses, their eyes will look bigger with the glasses on. All right, so just by looking at the size of their eyes, you can even tell what kind of glasses they're wearing. It's all right, I'm going to bring that back, let people finish that up. So again, I can have double concave. I can have convex concave. I can have plano concave. When it comes to our prisms, this is representing a diverging lens. It's as if we've taken one of these circular lenses and cut a strip down the middle and then turned it sideways so we can see what that profile does to rays. All right, so there is our diverging, there is our converging. Again, for diagrams on this, we already know what those definitions are. We don't need to rewrite it. Don't write down those things. Again, that says mirror, it should say lens. We've already wrote this from above. Notice the direction of the arrows now that represent the lens. That arrow is pointing up, so that's representing up here that it is thick on the edges. So with that arrow pointing up like that, that represents that it's thick. Now, these rays that I have shooting out here, I didn't draw them just pointing anywhere. They actually have to point in a certain direction. Where do you think those rays that are diverging away, where do they look like they're coming from? It's a lens. And whereabouts behind the lens? Where does it look like they're originating from? Pat, what do you think? The PF. And that's one of the things we're hoping to find. Just like the diverging mirror, we have to extend rays in behind to find things. Notice in this picture, the PF is on the front, where for converging, the PF was on the far side. And that's because when a diverging lens's rays spread out, they spread out as if they came from that PF. So the principle is now on the front. No need to write the definition. We know the definitions. That little f is the distance from the lens to the focal point. We've got a principal focal point and a secondary focal point. In this situation, there's nothing exciting about the 2f. So we don't need to draw in the 2f's for the diverging lenses. Nothing exciting happens there. But for the converging lenses, when we start drawing ray diagrams, there are interesting things happening there. So I think that we're pretty close to being ready to roll. I'm going to leave this up here for a moment. Yeah, we know that that's the principal axis. Yeah, we're not going to draw the rules yet because that's what our labs are going to be. So if you're done writing that, you can close your note up and you can get an iPad or get Google Classroom fired up. And under today's date, I've actually got 3 entries. I've got the note, and then I've got the converging lenses lab, and then I've got the diverging lenses lab. I've separated them into their own entries. We're going to do the converging lenses first, and then we will do the diverging lenses. And I'm going to save my movie first, and then I'll explain what we're going to do. So just give me a second to save my video. Is